PowerPoint certinho, né? Deixa eu... So, start second part of the program. I would like to invite Mr. Antonio Celso Jardim. I've already presented him, so it's yours. Thanks for coming.
Thanks, Jim. Okay, good afternoon. I will show here a presentation about the different techniques to measure isotopes in water. I have just 15 slides. The slides are Portuguese, but I speak in English. Okay. First, about science. We are proud to be a company in Brazil celebrating 40 years this year. I'm not celebrating 40 years with science, but almost 30. And we are proud to have our partners like Picarro, the best solution for water analysis isotopes. And also, we work with Picarro greenhouse gas monitoring, concentration, and also isotopes, and also with water. That's the solution that we are now approaching our customers. Of course, we work thermoscientific for many, many years, and also with Teledyne CPAC for laser ablation system that we combine quite often with multi-collector ICP-MS, resolution ICP-MS from Thermo Fisher. We also work with Swiss companies like Ion Plus, that we have the carbon-14 AMS to provide to our community. We have some plans to have one in Brazil. It's quite expensive, it's quite complex, but the solution that Ion Plus provides for us, it's the best one. We work with another Swiss company like Senti, Frag for sample preparation and also consumables that we acquire for high pure materials for our instruments. We also work with quadrupole process instruments from IPI Germany and also from other companies that provide sample preparation systems. So recently we signed with Proton, that the company that provides cleanup system and sample prep system for clumped isotopes, for carbonate clumped and also for gas, for methane and ethane. So we are proud to have special mass spectrometry here for clumped isotopes already in Brazil, for gas and also for carbonate. So I talked today about technology of stable isotopes mass spectrometers, and also we have some solutions including elemental analyzers and gas bench. So the mass spectrometer, it's a box, so we cannot take to the field, we cannot use in a bench top, and then we have to sit in the lab. So samples must come to the lab. It's a quite easy principle and traditional. We have a gas source, so I need gas. So I need to convert my sample into gas or extract gas from my sample. Then I feed the instrument with this gas that we have electron impact ionization source. So we produce ions that we accelerate and we separate by a magnet field, and we have a fixed array of detectors. So we collect here the molecular ions from gas species like nitrogen, CO2, hydrogen, and others. So this is the mass spec. So the same mass spec is able for you here to measure chlorine isotopes. We have techniques that we can convert the chlorine from water into a form that we can introduce as gas, H3Cl, into the mass spec. So we need to treat the sample to measure chlorine. We also have other kinds of mass specs that we can also use for chlorine using thermoionization mass spectrometry. So that's not the goal for this talk, but we never had a call for budget or research, including for chlorine in the water, but we can do. So the technology with stable isotopes also allows us to work with hydrology and measuring delta D and delta O18 in water. And then we have devices that we use to do this job. So it's a wide variety of applications that we can use not only for water, but also for wine. That's very cool. And also for traces and metabolic studies in humans and animals. So one solution that we use, not for water, but for solid samples, it's an elemental analyzer by combustion. Then we have a combustion in the box here, the elemental analyzer. We have auto samplers that we can use for keep our samples. And then we have a combustion oven. Then we have a separation by a GC column. Then we feed this gas to our RMS. So we can use these most for delta 15N, delta 13C, and delta 34S for sulfur. And then we can have huge application in agriculture, ecology, organic geochemistry, forensics, also adulteration, geographic origin, software chain, oceanography, and so on. So we have about 100 instruments in Brazil, and 80% of these instruments we have this kind of elemental analyzer because this is a strong demand from the market here. So this is the most traditional coupling that we have here available for stable isotopes, mass specs. So for this, we combust our sample, solid sample into gas. We have one instrument here, the operator is here sitting in front of us. And then we produce nitrogen and CO2 and SO2 if we have sulfur in our matrix. Then the goal is to transfer this gas to the mass spec and compare this gas to a gas cylinder that we have in the lab as a reference gas. So we compare the nitrogen sample peak to our nitrogen gas in our lab, so we can have a delta value, the difference between these two species. Then we have also a calibration procedure to get the true value or the expected value of our sample. So we do this with the mass spec, and then we collect the CO2 from our sample compared to CO2 from a gas tank. So we have the sulfur as SO2, and we compare to our reference gas. So this happens with helium as a carrier gas. So we need to have the instrument in the lab. We need helium. We spend a lot of helium. We need nitrogen, CO2, and SO2. So we need several gases in our lab in order to provide this kind of application. What happens is, since this is the most common arrangement that we have, and there is a huge demand for this kind of analysis because the applications, huge number of applications, we can also have another box like this, but with a different oven inside. So if we have our lab designed for multiple applications for nitrogen, carbon, and sulfur, also we can add another box with a different oven inside, and then we can also work with solid samples or liquid samples for hydrogen deuterium analysis and oxygen. The way we convert our samples, like water, into gas is we use a high temperature pyrolysis oven. And this oven is covered inside by carbon glasses, we call glassy carbon, coating and grains, and then we produce carbon monoxide and hydrogen as gas. Again, I need to have also carbon monoxide in my lab as a reference gas that is quite tricky to work with, and also hydrogen. But that's the price you pay to have a second box available in your lab sharing the same mass spec. So here in Brazil, as I mentioned, we have almost more than 80 instruments with the box that we use for carbon, nitrogen, and sulfur. But just a few ones to work with solid samples for hydrogen and oxygen. And just 2 labs running water. Among 100 RMS that we have here, just 2 labs are well equipped and with the methods validated to work with water or liquid samples. So that's why we think for the hydrology community, the cavity rig down spectroscopy option is the best choice, including also the budget proposed. So, but the motivation to have this extra box here for certain labs because they need also the mass spec for other proposals. So you add this box here, the budget or the investment is not too high. So how we do this? I can drop, we can inject less than 1 microliter of water in through our liquid autosampler inside on top of our pyrolysis oven. Then after conversion, we have 1 peak from hydrogen gas from the water. And then we have 2 side peaks here as a reference gas of hydrogen. Then I jump the magnet field and I look for mass 28 and 30 so I can get the carbon monoxide data. That means the oxygen 18 will be there, the information that we want. So at the end, we have maybe 6 minutes analysis time, more or less. Depends on how we set up the method. And then we can have 2 information in the same run. The hydrogen deuterium and the oxygen O18 from our water sample or liquid sample. So we do this, and it's quite robust. We need to run the same sample several times, maybe at least 3 times, in order to the first one to eliminate the memory effect for the previous one. And then we inject 2 other samples, then we have a mean value. So considering that we have 3 runs per sample, and then all the analysis time that is needed and all the previous calibration procedures that you have to do this, you can reach different applications for sure. And I calculate that you can do almost 960 samples a month. If you run 24 hours during 5 days a week. So that's the maximum that you can get. With this amount, also you need to include all the calibrations, the reference material, and the quality control standards, and so on. So that's about what we have here. And so the lab in Unesp Botucatu, he is able to, I don't know if he can reach this number here, but by my calculation, it's possible to do. So there's a limitation for sure. And during this time, you have to have a continuous flow of helium. The reference gas also you need to take care about using these gases in your lab. So, but this is feasible. So this is one way to do liquid samples. Yeah? The good thing is, of course, there's other application in forensics that you need to run solid samples, like hair analysis. The hair can tell where you are coming from, what your last, the signature that you have in your hair shows more or less your location. So it's famous cases in the US that you can solving about missing people and this kind of cases that we can use the hair analysis. So if you have hair as a matrix, you need to have this technique. Or also can work with wood, and you can also have this technique. So beside this, you can also do water. But the main purpose of your project maybe was solid samples. The second solution that we have is using a device called gas bench. So the gas bench is a box. In front of this box, you have an auto sampler. So this auto sampler is able to use one sample trail of 88 position or 80 if you prefer, and also can extend to a second box here. So we can have an extended trail. So what we have here, this is the method that we call equilibrium. So we don't convert the water into a gas. We add a gas to the water, like CO2 and hydrogen. Then we wait until we have the complete exchange. So the traditional method, before cavity Rigidal, before this online system, you used to do this equilibrium manually. You need to have an offline glass line, so you can prepare your samples, adding CO2 and waiting for the equilibrium to have the exchange. So this is an automated system to use a traditional system or traditional approach for water analysis. So the idea is to have a robot to do the job. So what we can do also with this box, we can also work with, of course, hydrogen material from water that we need a catalysis rod in our vial. Also, we work with O18 from water, but also can do other stuff. We can do O18 and carbon 13 from carbonates using the same device. So most of our gas bench here in Brazil are working with carbonates, not with water. So this device, we can do water for sure, but we need to stop and prepare the system to do water, but most of the demands are for carbonates. So we have several places doing carbonates here. There's a huge demand to do carbonates, and this is the best device that we can. Also, we can do inorganic dissolved carbon with this technique. And also can do, not very often, CO2 from air, and O16 from oxygen from air, and O17, O16 also from air and water. It is tricky because the mass spec should change. We should add more collectors. It's not so easy to do this. And also some nitrogen from air. So this is very rare, but DIC and carbonates the big demand for this device. And also water.
Because of pressal.
What?
Because of the oil at pressal.
No, it's for stratigraphy purposes. So we have several universities running this instrument, not for service, for oil companies, but for their own purpose. So it's a very common technique. So what we do with water, if we decide to use our gas bench for this one. So we place in 12 ml vials with a cap. We pipette about 500 microliter of water, or 200 microliter, it works as well. And then we add the catalysis water. So the sample here you close immediately, and then you have a period of time that you have to flush your sample with a mixture of hydrogen and helium. So you flush, you get rid of the air, and then you leave the hydrogen for 2 hours. Then you return to the same vial and measure the hydrogen gas after equilibrium. So the catalysis rod we have here will speed up the process of equilibrium. So we expose this catalysis rod to our reference material, reference water. Also, we expose this technique to our quality control reference material in the lab. So there's a robot to do this. So we flush 80 samples. And then after 2 hours, we return to the first sample and start collecting the gas. The flush period is 15 minutes, and the analysis time is 15 minutes. So at the end, each sample will be exposed to the same equilibrium time. So we need to do some calculation about how many samples we put in our trail in order to see that the first one the gas will be collected after 2 hours, and the last one as well. So this process, when you run the mass spec for hydrogen, you run all samples for hydrogen. Then you return the samples again, and then you inject a mixture of CO2 with helium. Same vial, again, you flush, get rid of the hydrogen, and then you wait 20 hours. So after 20 hours, you have to return to the same vials and measure the gas that was the CO2 that was exchanged with the water, bring the oxygen into equilibrium. So this is some tricks behind this, because you also have to consider some data reduction, considering the drift that you may have a long time, and also you have to add several quality control standards to your trail. So the calculation means that it's a long process. So you have to feed the instrument with many samples, and then you have to run one sequence, then another one, and at the end you have both data. What we have here for the gas bench that enhances the precision is that we have multiple loop injection. So we have our gas inside a 12 ml vial, and this CO2 that is sitting there, we have enough sample to inject our sample several times. So the mean value of these results for 018, for instance, will give us a better internal precision of our data. So in this case, we have a kind of, if we work with equilibrium, at the end, running hydrogen and water, you just can get 800 samples per month. So we don't need to run your sample twice or 3 times, just once, because we have internal sampling system that can provide multiple injection of the same gas that was equilibrated. So this is about the productivity using this system. Just one lab in Brazil is doing this analysis for oxygen because it's regulated by the International Wine Organization. So they need to run this method by equilibrium to control the water addition to our wine. So they cannot use pyrolysis methods. They are not using erythritol for wine control because they are following the regulations from Europe. So it works. They feed the system with 20 samples, and this is enough for them to run the routine. So there's almost no sample prep. Just put your wine. Also, it's used for juice. So water addition to juice is regulated also in Brazil. So that's the idea behind this gas bench. Let's say we have maybe, I don't know, 15 gas benches in Brazil. 90% is doing carbonates, and the other just one doing water equilibrium for wine. So, but it's a technique that's available. So here we have the solution using elemental analysis and pyrolysis will give us for 10 samples external standard deviation of 2 per mil for hydrogen. This is our uncertainty, and 0.2 per mil for oxygen. Cannot do better than this. And if we use equilibrium, we have around below 2 per mil for hydrogen and below 0.08 per mil for oxygen using equilibrium. That's the goal, and it really works. And also this can be better than 2. We know that, and this is about 0.2 per mil. This is external reproducibility. So that's the solution that I want to show today, because we could have much more to show about water, because we can do, of course, we can offer for you different mass specs for different proposals. For instance, like here at UNESCO, you have noble gas mass spec. So soon we have a project here that we can do helium in water. So there will be helium isotopes in water, and also we can measure the noble gas. So the idea now, the project is to move ahead. The mass spec, the most expensive part is here, running very well, at the Geoscience Institute here at UNESCO. So the plan is to have a line here for water analysis. So it'll be very cool. DGA will be participating with this project. So the sponsorship comes from Petrobras for this project. And also recently they acquired a Picarro system for water, for oil field production. So this water is very high content of salts. So we have this device for salts prevention to get into the system. So we are running salt water there as well. So the solution here for water can be also done by isotope operation mass spectrometer that also can use for other purposes. So that was the goal of our presentation today, and we are celebrating 40 years this year. We're very proud of this. Thanks.
Questions? So first of all, thanks for the invitation I received. How are you planning to go? I have a question regarding the pyrolysis system. So we received some oxygen 70 results. Can I believe on that or not? I don't use.
Well, the mass spec must be prepared for this. So if you don't have the mass spec prepared for this, this data it's not used. Okay, if you want to do a proper job for O17 with stable isotopes, it's a different apparatus that you need in front. So I think if you have triple oxygen in silicates, then you have to use a mass spec. Then you have a special device with laser and bromine pentafluoride to convert to O2. It goes to the mass spec, and you have a very precise data. But for water, we don't think so.
Yeah, because the results are the same. We don't have variation. So.
No. I think for these, the best solution is have the ring down.
I have another question.
last method you showed us,
Equilibrium.
equilibrium. So I remember in the time people used long line with glasses, and but my concern is about methodologies for deuterium analysis, which is the difference between, because you are doing the method, the equilibrium method using optic.
Yes.
But there is another one using
Chromium.
chromium, yeah.
Okay. We used to have a device that we have at USB. You can turn it on and can put it to run again. It's not commercial available anymore. We inject 1 microliter of water, and then we have a chromium reduction with ultra high pure chromium in an oven under 800 degrees. Then we produce hydrogen gas, and we analyze by doing that.
Okay.
And this precision is very good. And this device used to work very well. Can work again. It's the region is ahead of this. So this device is a traditional method that we use to convert offline prep systems to a kind of online, but it works just for hydrogen. It works just for hydrogen. So you need to have this device called H device for hydrogen, and then the same water have to put again different vials for equilibrium with the gas phase.
And then use
Yeah. Doing that. So before the Picaro, USB used to run like this. Now the Picaro there, they use the gas bench for carbonate, 24/7. Unbelievable. It's Chico Bill's work, Francisco Cruz, with using tapes and so on. It's amazing work. Roberto?
Yes. Regarding the noble gas analysis, I understood you have the main device is here, the laboratory to monitor, yes? Or this?
It's
The component of the laboratory monitor?
no, the mass spec was provided by Petrobras,
Yes.
a big project. So the purpose of this instrument here is to measure
Gas content from the deep ocean.
helium and argon and no, not xenon, krypton. No, no, neon, argon and helium ratios from natural gas analysis. So our prep device was designed to purify the gas so we can run different steps in the mass spec. So the mass spec's general purpose noble gas mass spec that we have here. So the idea is to provide a proper line for helium from water.
Yeah. How long do you think it's going to take to the system running?
I don't expect less than 1 year from now.
Expect more.
Yeah. We are in the initial steps of this project, but at least we have the mass spec running and under good condition here. So also for carbon-14, we have just one AMS in Brazil, in Fluminense Federal University. And I'm not sure if they run water there.
The problem to run water there is the prep system. So
They don't have the press.
they don't have that. You need to concentrate bicarbonate and produce this
Yes.
material. It's not difficult to.
Yeah. We see in Brazil that
They are not interested on water. They have other interests.
they are working for plastic, from ceramics, for whatever. So this workshop is nice because last time we were here, we were talking about these rare earth critical minerals, and the most important mineral that we have is water for our life. So
According to some geologists, water is not a mineral.
Well, it's a resource.
Yeah.
So, but the amount of resource that we apply, other fields here in Brazil is much higher compared to water. So we see so nice and cool presentation this morning from the students. So there's a demand for this. So unfortunately, if you want to date water, then you have to submit samples to Beta Analytics in Florida. Then you just have a number or age, but we're not participating in the calculation of these and so on. Maybe not. And also, we don't have our AMS available for this proposal. Also for noble gas, we're starting now with this project. And so we still need new devices for water, for sure. It's never end.
It's true.
Yeah, just to add a comment that the carbon from 14 is a big bottleneck in Brazil. So we are the ones, some among others, that demand many carbon 14 determinations all over the year, and it's a big mess to send the water samples to Canada, to Holland, whatever. You have to have an international project to give the support for that so that you can handle all the customs issues and noble gas. I mean, it's even worse. And if you don't have a project funded by the agency or the European community, whatever, it's nobody's going to pay for that so far. So, but this is part of our responsibility here to raise the demand and saying that this is very important to water management. Otherwise, you build the whole management system on top of very bad data or with no ages. So this is part of what we need to do.
Recently, Australia did this huge project for treatment water, old waters. So imagine, it's a very special line. So, but the CSIRO was funded by for the main government because they have a proposal. They need water for agriculture, groundwater, and it's tricky there. And so here in Brazil, we are, I don't know.
Nobody realized how much water actually we have, and everyone thinks, okay, we have a lot of water. We live in a water country because we own 25% of all the water in the.
Don't say this to the US, otherwise.
Yeah, but it's,
Yeah, but
is the current talk about our here. So everybody remember about water when you don't have water in the tap.
So I think there's a huge demand for have the labs available to run more and more. And so that's my only advice. Thanks.
So now I would like to invite Professora Veridiana Teixeira de Souza Martins. She holds a degree in teaching certification in geology from the University of São Paulo, where she completed master and PhD in geoscience with a focus on geochemistry and geotectonics. She has been a faculty member at the Institute of Geoscience since 2009. Her research focused on isotopic geology, particularly the use of hydrogen, oxygen, functionally isotopes to study groundwater recharge and contamination. And more recently, she has worked on natural disaster prevention, emphasizing risk perceptions and education. She is affiliated with several research centers at USP, and we collaborate in many research aspects. And also, I would like to emphasize another woman doing science and dealing with isotopes. Thanks, Peter.
Thank you. Thank you very much for this invitation. The idea here is to talk about the good practices in laser spectroscopy. So I think we have the oldest Picarro in Brazil. We have Picarro, our Picarro is with us for about 10 years now, I think. So it's still running, and we just passed through the Wyckoff test again. So we have a we have a
Good rate.
Good rate from the international agents. So let's talk about the good practices. We have learned a lot for this year. So the good laboratory practices begin in the sampling campaign. We need to have adequate sampling bottles. Sometimes we receive plastic bottles, but we prefer amber glass. It's mandatory to avoid air bubbles inside it, and they must be sealed with plastic bung and cap, because sometimes we receive samples like this one, like this one. So this sample here should fall within the orders from the same campaign, but it is here, down here. So this is a sign of evaporation, and the evaporation is just because of this bad close-up of the closure of the flask. So Celso already told us about the IRMS, the traditional isotope ratio mass spectrometry. This equipment has one sample, but with two different liquids, in our case at USP, because we have the gas bench and also a IH device. And it provides us to work with two different liquids of the same sample that does not run in the same equipment configuration. They are different and at different times, sometimes in different periods of time. And then we have the laser absorption spectroscopy technology. This technology provides us with just one sample, one liquid running at the same time and in the same equipment configuration. This give us better results, because this I extracted from a paper from Wassenaar, Leonard Wassenaar, and their group said that because less performance equals or exceeds most IRMS for delta 2 hydrogen and delta 18 oxygen measurements of environmental water samples at lower cost. This technology is quickly expanding into laboratories that do not have isotope analysis experience. There are several challenges in obtaining high quality results. So my objective here is to inform or to prepare other laboratories to run with high quality this kind of equipment. So we have to know the limits of each equipment in the lab. Some equipments like the lasers one, they have some problems with high salinity samples. So sometimes you have to understand your sample, and if the equipment is not affordable for it, we have to run the sample in the RMS. So we also have to know the stability of energy, gas flow, chamber temperature, vacuum, gas purity. All of this is a key question for the best practice in many lab. Some samples have to be pre-treated, filtered sometimes, because people take samples not filtering in the field, and sometimes you have to filter it to avoid the documentum, cartilage. I don't know the end. It's in another. Clogging the syringe. Thank you. So, Wassenaar and his colleagues also provide another paper about the results of the intercomparison tests they provide along all over the world. And in 2016, there were 235 labs worldwide. Just 73% of them provided acceptable results. So we have almost 30% of the labs running isotopes for hydrogen and oxygen that are producing results not acceptable. The top performance for delta 18 oxygen values was dominated by the dual inlet IRMS laboratories, and the top performance for hydrogen delta values was led by laser spectrometry laboratories. So the first learnings we had at USP with our Picaro is to change the syringe from 10 microliters to from 5 microliters to 10 microliters to avoid the clogging. And we also learned not to exceed the neck of the vial with water, because sometimes if it's full of water, sometimes there's a pressure inside, and the syringe comes empty, comes out empty. So we just left some space here. We also have this action. We leave the high TDS total solid samples for the end of the run, because sometimes if you are not in the lab in that period, the syringe must maybe it is clogged, and you are going to lost all your run, all your samples. This kind of equipment has a memory effect important. So we work with at least 7 injections to discard the first 3 injections per sample, but we have the best results with 9 injections. The secret of any lab with good results are these. How can I say, the container for standard storage. These are the containers at the EAA, and it provides, we can put here 20 liters of the internal standards, in-house standards, and then we put a tube that are going to take the water sample from the bottom of this container, and this container is also pressurized with nitrogen gas. So these containers maintain the integrity and avoid evaporation loss and fractionation of the standard. So it's a 30 liters container, and we put here 20 liters of our standards. We have 3 of this. Okay. We have the IAEA has a PDF document with all the directions to construct this. We don't have this to already done to sell for us. We have to build it. So in each run, we use at least 2 ml of 3 internal standards. So we are going to use this every time we are going to run samples. We have a 2 ml high delta value, a low delta value, and the control standard that is in the middle of this other two. And the control standard is to measure analytical quality and precision. These vials are glass, amber glass, but they have a cap with a rubber that's going to be punctured by the syringe. And once this is punctured, it can be stored no longer than no longer than 2 or 3 days. And in the fridge, this not punctured vial can be just stored for 1 month. After this, these standards are going to fractionate. So we have to take again from our container standards to analyze in another month. Okay. So standard values should have a range included in the values of samples your lab will analyze. We have this discussion with the people from the IAE because most international standards, VSMO, GIS, or SLAP, they are negative standards, but we have some positive samples analyzing results. So we need some positive internal reference material to compensate the lack of the international standard. Because if you just have to correct the negative ones to correct our samples, the positive ones could be some variation, could have some variation. So before the run, we have to perform the drift precision test using the control standard. We put 150, we put just 25 vials that will give us 150 results. And we have an Excel file provided by Picaro that's going to give us the information if the sample passed or failed. Because these results should be the same all over this run. And sometimes we have some variation, like here in the blue are the oxygen results. It's not good, they fail here because we have to be under, or we have to have lower results than this number here in this column. So we provide, we do this before every run, just to guarantee the equipment is running perfectly. So during the analysis, we have to check if vapor concentrations of the samples is around 20,000 ppm. And if it is not the acquisition, during the data acquisition, if it's under this, the result can be with some inconsistent. So we have to maybe stop the running and go back and provide more volume of water greater than we are using to achieve this 20,000 ppm of water. Another thing we have to do is to look for this peak here. This peak should be flat and not inclined. If it's inclined, we have to change the septum or clean the vaporizer. So these are things we have to pay attention during the analysis. This is very important. Sometimes this is very steep here, and we have to stop the running and begin again. After the analysis, it's very important to perform ChemCorrect. The Picaro has a database that will correct the occurrence of some organic compounds into your sample. And the database of Picaro is better than the database from Los Gatos. So this is an information we have in the IAEA. So if the ChemCorrect show that we have some organics, we cannot report these results to the users. When we are submitted to the WICO test, the intercomparison test that the agency makes, they sometimes send us some samples contaminated with organics, and we cannot send them the results. So if we need to report this because we were paid for, we have to run this in the RMS. Okay. And the other thing which is very important is the data process. We use the LIMS for lasers from a group of UGS and also the agency, and they provided computer program running Access. I don't know if they are going to change this because Access is not more available with Microsoft, so it's a problem. We have to install in the Windows, previous Windows to use this, but it's a very important thing to do. We use the bracketed normalization because the bracketed normalization works with less samples, results, and minimize the memory effect. We also do a correction for between sample memory. That it should be lower than 2%. The computer gives us, the software gives us the results of our samples. And we also can look for outliers and mark to ignore them previous to the normalization with the international standards. So we use this to provide the results to our users. And we think this is better than do our Excel formula to calculate and deliver the results. So I'm finishing, but this is one example of the results from the WICO test that the agency provides us. And if you can see here, this is for delta oxygen, delta 18 oxygen. Each point, black point here, is a lab that sends results for them to analyze. So the result, the correct result should be on this 0 line here. And you can see there are labs providing results over the maximum range and lower for the same sample. Okay, the same thing for the hydrogen isotope. So the results should be here on 0, but we have some labs delivering results for their users like this and like this. Okay, so the recommendations. Provide internal standards because the international agency, we can just buy 3 samples, no, just 20 ml of each international standards each 3 years. So it's not going to be sufficient to all your running samples in the lab. And also participate in the WICO test. It's an opportunity to track the lab quality and to improve lab procedures. And I want to ask you for a favor. Please do not use just 18 oxygen and deuterium analysis when you are going to ask us for analysis, because when you do so, you are asking just for the oxygen 18, but the delta value provide us with the 18 and 16 and also the deuterium and the hydrogen isotopes. So this is a bad simplification of the result. So I think that is it. Thank you. And
Somebody else has questions? Next time I won't invite. You make too many questions.
Good job. Thanks for the presentation. Organics. So we are very willing to do superficial water, so stable isotopes in river water for engineer purposes and for research projects. So a normal river, there is a normal river, but imagine we are here in the river next to the
Pristine river.
yeah, to the pristine river city. So if we take one of those samples, we have to run for organics, or where do we? How can we know?
every sample you have to put the chem correct to see if it has organisms.
Let me ask you this, the other two questions. So this is one question. So organics. The other one was so we didn't pass the exam for WICO.
Okay.
Our lab was just in a very immature installation process. So we tried because we think it's very important. We passed on the deuterium. Deuterium was good, but our oxygen 18 we didn't pass. So it was a very good lesson, so that we have to improve our and lots of issues in the lab. The second question I have forgotten. The first one.
So every run you have to pass through the chem correct first prior to go to the data compilation and normalization. If the result, we run some samples from rivers and we didn't have any problem because the database for Picaro is better than the Los Gatos. I don't know the Los Gatos database. Each equipment has a database that will, how can I say, identify and then correct the presence of the organics in the results. So if the flag is red, because the Excel file, it will give you a blue and green and red. If it's red, you cannot, that sample is not suitable for laser analysis. You have to run it in another RNS. Right? We have so many problems. We don't have problems with organics. It's very rare to have this. Okay?
If I may add, if it gets
Yeah. I will ask exactly about not yeah. I will ask about the chamber, the combustion chamber.
So if it does get flagged at that point, then you can take it and run it through the microcombustion module that sits behind the car, and that gets rid of your organics, and then you can measure it. So you don't have to go to IRMS if you have that extra module. Not yet.
But I have a
Another question? So my question is, if I bought or if I buy the barrels, can I put some beer inside?
No.
Ah, come on.
No, that's organic. So you contaminate your.
No. So you mentioned about LIMS and about the Tahoe system to evaluate the results and to make the corrections. I know some people that use the internal correction system limbs or los gatos, doesn't matter. And some people use limbs. I would like to hear your comment about that. I know that the agency insists on using limbs. There are some reason, but
We, in the beginning, 10 years ago, we did some comparison with our, we have a method to do the correction in the RMS. So we brought it to the car and tried to do some corrections to see the results. And then we compare these results with the results with we passed through the limbs some years later, and they are more consistent when we use limbs. And the advantage of limbs is that it gives you the quality. It has a QC track for your lab, so you can also see if your control standards is always running the same value along the years, and so it gives me more confidence. Prefer limbs, okay?
I have another question. How many results you need to have a good internal control? So how many injections you have to do? For example, we are looking for very negative water. I'm planning to go to Andes to get some snow, some ice. And also we are looking for mineral water from the coast in Brazil. I had some results close to zero, so I think it's a very good standard, positive standard. How many injections you have? Okay, my results are good. This sample is good, or this water is good to be become an internal standard.
I really don't know because
You can
we-
maybe you can mention how is the standard deviation
okay.
need to reach to be sure that this sample has this isotope.
Okay, the lower than 1 per mil for hydrogen,
Yeah.
and lower than, I don't remember the oxygen,
Point
0.8.
3, 8.
And I don't remember really. I can look up in our computer.
Yeah.
But we have a sample we took from a well in Recife.
Okay.
This,
So
yeah, it's 2.
Two.
2, plus 2.
plus 2 per mil.
Yeah. And but it's with high salinity. And then what we did, we brought it to São Paulo, and then we passed through the iomizer,
Yeah.
and then we put in the barrel, and after that we calibrated with the international. We did this. This is the +2, and we have Evia, -7, -8 for oxygen. And that's it, because we had some glacier sample, but it was stored in a detergent container, so we were afraid to use it as a standard because it was smelling. And we just, so if you're going to Andes to collect some, please remember us.
Bag.
Okay.
I would like to go to France to have Evian in the search, but probably it will be impossible. So, any question? Thanks, Viviana, for the nice talk. And now, we move a little bit on delay, but not too much. For the second talk, here we choose different applications of isotopes, and we have special guests for talking about different applications and different isotopes also. I would like to invite doctor in geoscience, Ana Paula de Jesus Rios. She is a specialist in hydrogeochemistry with focus on natural anomalies. She began her journey in the field during her undergrad studies. Her master research explored oxygen and hydrogen isotopes within a natural barium anomaly in Bauru Aquifer. That's a very problematic issue in this zone. And during her finished PhD last week, she expanded her expertise to include also chromium isotopes investigating a natural chromium anomaly. Also, I would like to invite Mr. Rafael Baceto Ferreira, over there, from Unicamp. He's a PhD student in geoscience at Unicamp, focusing on hydrogeochemistry and geochemistry of rocks and soils in the outcrop area of the Guarani Aquifer, doing a very good job on earth elements, earth elements. I would like also to invite José Lucas Martins Viana. He's a PhD candidate. You did your no. It's not you. Sorry. He's a doctor. Holds a PhD in science, analytical chemistry from the University of Campinas. If I read all the instructions, probably I won't commit this mistake. And is currently a postdoctoral researcher at the São Paulo State University. His research focuses on analytical and environmental chemistry, particularly on elemental speciation at the sediment-water interface, contamination by organic and inorganic pollutants, the use of diffusive gradient in thin films, DGT technique, and environmental risk assessments. And Mr. Jesus, I guess I won't be able to say Jesus. David Gomes Gutierrez from Unicamp, but also from the Instituto de Geología Costas y el Cuaternario de la Universidad Nacional de Mar del Plata. So, I don't have any information about you, please. You can provide it. I know your advisor, so I know the group from Mar del Plata, Daniel Martinez and Orlando Mauricio. I just sent an undergrad student to Argentina. I hope you receive Nicholas very well. So I would like to start inviting Ana Paula to give us.
Good afternoon. This project is to talk about the use of isotopes of oxygen and hydrogen in this contamination that there is in the city of San Jose de Rio Preto. First, I'd like to remember about everybody here knows the importance of oil, especially for the drinking water. Because in the state of São Paulo, about 80% of all the cities have a groundwater supply. Sometimes they are full supply, sometimes they're just primary supplies. In São José do Rio Preto, it's a mixed supply, and it's located in the Bauru Aquifer system. In the Bauru Aquifer system only, the wells that are monitored by CETESB, 11% of them have the chromium amount above the drinking water limit. And in this study, we found the concentration of 0.13 milligrams per liter, and the quality reference value for this aquifer is 0.04. It is a number higher than the rest of them, and the number we found is really higher than the one that we cut the reference. value. But at almost 160 kilometers of San Jose del Equator, there is a city named Urania. And this city has been confirmed that it has a natural chromium anomaly, and this anomaly it has the same, almost the same geology, and values are pretty close to the ones we found there. So what's the objective? Our objective is to find how the anomaly is it geogenic or anthropogenic, or does it come from a single source, does it have more than one source? Understanding this anomaly is important for AD. The city of San Jose del Equator is located at the top of the Paraná sedimentary basin in the Valley. This basin has a deposition by an Arroyan fluvial system that already shows that the deposition was not homogeneous. And there, the immunity that you can find from the Valley aquifer system is Aquifer China, Aquifer Anastasio, the Aquifer Isotope, and the Aquifer Serra Geral. And as I said, that the mixed 57% of the water supply comes exclusively from the Valley aquifer system. So we have there the chromium 6 anomaly. What's the problem? The chromium 6 appears in the water with the oxidation state of 3 and 6. 3 is good for you, and 6 is not because it can even be carcinogenic. The reactions between the 3 and 6 is what causes the fractionation of this element. And we do have that the difference between the anthropogenic source and the organic source can be seen by the value of the isotope. As an important case, that one of the oldest case, it's the case of anthropogenic contamination in the Uyghur Desert. Using the chromium isotopes and the hydrogen and oxygen isotopes, you could see the path of the plume and the mixing of the waters where it was coming throughout the mixer, and with the chromium isotopes, you can see the reaction. The techniques we used for doing this study, we created a big database that becomes a shape files. We sampled 72 production wells. We got 3 rainwater samples and 1 spring water sample. We did the chemical analysis of the elements. We used the element for doing the isotopes of hydrogen and oxygen, and we did an approximation with the Johnson Labs to make the isotopes of chromium analysis. What was the result that we have? At first, we didn't find any type of correlation between the contamination in the area. As we can see, it's all around the contamination. And as we looked at, there also happened the wells, wells deeper and the shallower. One of the problems was the low quality of information, because since we had from other entities, most of them did not have a good geology description or none at all. The same thing happened for the analysis. And the filters, so most of the time, getting more than one information. Adamatin information and the Santana information. And most of the time, going to the top of the Serra Geral. So that way, you have more than one source of elements in the water. However, we were able to understand that there are 3 main clay layers there in the city. One located in the middle of Adamantina, one in between Adamantina and San Anastasio, and one at the top of San Geral. However, at a short distance from the wells we had, with the ones that have the good geology description, you can see that it's very, very different. Most of them do have a clay layer where it should be, but most of them didn't, and sometimes they have more clay layers or even none at all. And all of these layers, sometimes they show also, these clay layers, they could work as traps, making the mixing between the waters, between a shallow water and a deeper water, different. It could trap the deeper water. It could do all sorts of things that could change what's happening in the river and on that well specifically. What we do have of different that we found is this well over here that is located under a tannery. And we got there and we found clear indication of anthropogenic influence. The rest of the wells are located in mainly residential areas and didn't have any source of indication of an anthropogenic influence that could release primary water. So we did the isotopes of hydrogen and oxygen, and we had 3 water samples. However, these 3 water samples, they come in the lower precipitation area because, well, we left them there from March to October, and we were able to collect only 3 samples because there's rain there. And what we were able to see that there is an water mixing. And this could be a mixing of the water, shallow water. And this could be interfered, and there could be difference of the composition, could be interfered by the existence of flood traps. Because you can see that the more deeper waters have more chromium than the ones that are often rich. This is not a rule, however, but it do looks like that the waters with higher concentration have a lower number of the deltas. But however, we still don't know if the source is the same or if it's 2 sources, or if here would be geogenic and here could be anthropogenic due to the profundity of the waters and the relativity of source. So that's why we did the isotopes of chromium. The isotopes of chromium, they showed us that the anthropogenic sources, they do have a value of 0 because it's close to crust and looks like the ore. Since the reactions happening, the value they increase. So all the values that we found are positive, with the exception that sample that look like anthropogenic that has a very low, very low value. And we do see that the samples that have the higher chromium also are a little bit lower, showing that they didn't suffer as many reactions as much as the samples with the lower concentration. So the conclusion we get is that this is a complex anomaly, and it happens at different depths. So it's very different. It's very difficult for us to say what can do. They happen at an expensive location. It happens at nearby sites. As for an example, I have a site, a well that we have 0.02 milliliter and 600 meters. By it, you have a one that has 0.8, 0.08. And we do have the very different heterogeneity and the presence or the difference of the clay layers. What could be happening is that the mixing or the reaction that is happening in the samples could be the reason why you do have some lower chromium, lower chromium with higher ones, and reverse for the others. So I mean that could be the sources, or that's why the deeper water are closest to the source once it has suffered less reactions because the has a lower value of the chromium hydrogen. So this could be one reason of the mixing is the water sometimes blow up, they suffer reaction or less, or they are trapped in the mixing layers and could be reacting because we do have some layers that has indications that we have a reduction or an oxidation. And as we still need to know if there is one or more source. If the isotopes of oxygen and hydrogen, they are different because they do have different waters of more than one source. And that can be done by analyzing each layer specifically to understand better the signature of the three elements in each one of these places. But we were able to confirm that there is a mix of waters and the anomaly is present.
So, next week, Rafael.
Eu vou fazer uma apresentação em português, para ficar legal. Mas a apresentação está em inglês. Eu vou falar um pouco sobre a parte da minha tese, doutorado, fazendo TM. O título do trabalho é Hydrogeological Conceptual Model for a Guarani Aquifer System, Outcrop Area Integration of Stable Isotope in the Ray. É importante a gente ter uma relação, né, da conexão entre água superficial e água subterrânea para a construção dos modelos hidrogeológicos conceituais e no gerenciamento das águas também subterrâneas. E algumas técnicas para isso que podem ser ajudadas são a combinação da hidroquímica clássica já utilizada com dados de isótopos e de elementos terraçários e líquidos. Então, nós buscamos, né, determinar a concentração dos isótopos estáveis, dos elementos terraçários e líquidos, em água superficial, nascente, água subterrânea profunda, né, no sistema aquífero do Guarani. E, a partir disso, estabelecer um modelo conceitual da área de afloramento do aquífero. A minha área de estudo aqui é o aquífero Guarani. Minha área de estudo aqui em São Paulo, em Analândia, na bacia de cabeceira do rio Corumbataí. É a bacia aqui. A gente tem rochas areníticas, né, forma a unidade aquífera do Guarani, que são o Piramboia e o Botucatu. Tem rochas do Itaqueri, que aqui a gente considera como o aquífero Bauru. E tem o aquífero fraturado Serra Geral também, né? Nós coletamos em agosto de 2022, né, um período seco, foram 9 amostras de nascente, 7 amostras de água superficial, 2 amostras de água subterrânea rasa, né, seria de um poço tubular profundo, mais de 60 metros, e de um poço cacimba, esse aqui é no aquífero Bauru, e 5 amostras de água subterrânea profunda, de poços com em torno de 200 metros de profundidade. Fizemos as análises de cachos, por ICP, ânions, por cromatografia iônica e os isótopos estáveis em planejador de isótopos. Resultados, bem rapidinho a apresentação. As águas subterrâneas profundas, elas são bem mais empobrecidas, são esses círculos azuis. O poço raso, né, o poço super profundo do aquífero Guarani, 60 metros, ele é mais empobrecido em relação às amostras de nascente e água superficial. Não há uma diferenciação entre as águas superficiais e as nascentes, e entre o poço cacimba, que é essa estrelinha aqui. São todos em torno de menos 6,5 de alta oxigênio e em torno de menos 40 de hidrogênio do teto. Uma amostra apresentou o processo de evaporação. Ela tem um reservatório acima dela, água superficial.
a gente vai olhar a química, a gente uniu aqui a química clássica, o diagrama de Piper, com os resultados de ETR. E a partir disso a gente criou novos grupos para interpretação. Então, um primeiro grupo seria nas amostras de água subterrânea profunda, onde elas são bicarbonatadas sódicas e mostram o processo final de um aquífero SAG confinado. Um grupo, né, segmentado em duas partes, com águas mistas, né, elas podem ser cáusticas, um ponto também, mas mistas e bicarbonatadas e coletadas nitratadas, porque a gente incluiu o nitrato na análise, que podem ser formadas por um grupo com menos, né, considerando concentração de inferior a 0,1 micrograma por litro, e concentração média de ETR entre 0,1 e 1 micrograma por litro. Aqui onde ficam as águas de nascente de água superficial, mostrando aqui nem os isótopos, que não há uma grande diferenciação entre elas, assim como do Poço Cacimba no aquífero Bauru. E tem um grupo, o grupo 3, com alta concentração, né, na nossa área de ETR, e que envolve uma nascente, uma água superficial e o poço raso do aquífero Guarani, onde as concentrações de ETR são elevadas, acima de 1 micrograma por litro na nossa área, e tem alta concentração também de nitratos, né, que a gente associa a uma contaminação antrópica na área também. Juntando os dados, a gente propõe esse modelo para a nossa área. Aqui seria o aquífero Guarani, com circulações rápidas, médias, né, no poço profundo do Guarani, que é esse aqui, nas nascentes, com circulações médias também, comparado com o aquífero Bauru, onde é bem mais rápido o tempo, né, de residência é menor, as circulações são rápidas, tanto que não há uma diferenciação do poço raso para as nascentes da região. E aqui, o poço profundo, com uma química diferente, que nem a gente vê no Piper, só que quando a gente vai avaliar isso em relação aos modelos já propostos na literatura, aqui essas águas elas estariam bem mais confinadas no Guarani, a 20, 100 quilômetros de distância da área de afloramento do Guarani. E na nossa área a gente encontra esses dois tipos, né? As águas bicarbonatadas cáusticas, das nascentes, água superficial, assim como a água bicarbonatada sódica, que se é encontrada na parte mais confinada. Então, os modelos eles não consideram na área de afloramento esse tipo de água. O que a gente está propondo aqui é incluir, né, uma avaliação da área de afloramento, saber que também tem águas bicarbonatadas sódicas. Isso para gerenciamento, né, dos recursos hídricos é super importante. Que é uma das considerações finais. Então, nós propusemos utilizar o Piper associado às considerações de ETR e avaliado com os resultados dos isótopos. Eles contribuem para a construção do modelo hidrológico conceitual da nossa área e nós conseguimos perceber, então, que na mesma área de afloramento a gente tem esses diversos tipos, faces hidroquímicas que geralmente não são consideradas na área de afloramento do gás, do sistema aquífero Guarani. Bom, é isso, foi bem rapidinho. É isso. Obrigado.
Lucas.
Good afternoon. I'm Lucas. Lucas Viana. I'm a postdoctoral researcher here at the Environmental Study Center. And as you may notice from the title of my presentation, my work is not really into the isotopes that were presented before. I am part of the my research group focuses on the methodological and methodological development for trace elements in the environment. And here I'm going to show you some results of my PhD work, which was really known here. Everyone here knows that the sediment is a very heterogeneous metric, which means that we can easily find gradients of pH or oxygen, organic matter, and of course elemental distribution and different kinds of elemental speciation at a very short scale, and even at the millimetric scale. In this work, we focused on microniches, which are very small spots where they are usually rich in organic matter content and organic matter degradation. So it's a they're a very important sites for metal mobilization and changing metal speciation as well. And these features, although they are very important, they are very difficult to be visualized, especially because of how we collect sediment. And so we usually lost these features. But these can be achieved by using alternative sampling methodologies, such as the diffusion gradient in thin films, which is the main technique that we use here at the Environmental Studies Center in our research group, which is a passive sampling that consists in a series of different gels with different properties. And this technique is based on the migration by diffusion of different elements through a diffusive layer, which is usually a gel of agarose or polyacrylamide, towards a binding gel, which is also agarose or polyacrylamide, but with a fine distribution of a binding agent such as Kilex, for example. And the good thing is that we can analyze these gels by laser ablation, so we can have as a result an image of the metal distribution. So as I mentioned, we can analyze them by these gels by laser ablation, so we can obtain an image of the metal distribution, and the quality of this image and the quality of the features that we can visualize are linked to the resolution of the analysis. So in this work, we use the DGT to access the distribution of uranium and other associated elements in highly contaminated sediments. So we went to Caldas Decommissioning Unit in Minas Gerais state. It was the first mining industrial complex in Brazil, and it was operated in the 80s, but it generated millions of cubic meters of mining waste. And today, this region is under decommissioning plan, which means that they're trying to minimize environmental effects caused mainly because of the acid mine drainage. And in fact, we analyzed the sediments and we saw that especially in the catchment ponds, which is like where the acid mine drainage is stored, the concentrations of uranium are very, very high. So we went there, we deployed the DGT devices into the sediment water interface. We used a mixed binding layer consisting of Kilex and titanium oxide for 24 hours. Then we validated a drying methodology to avoid the cracking of the gels because they're very fragile. And also so we can use them in the laser ablation chamber. And of course, we analyzed using a laser ablation coupled to an ICP-MS and ICAP TQ from Thermo Scientific. And we used two different approaches. As I mentioned, the quality of the images depends on the resolution that you're using. We use a standard resolution, which is the resolution that has been used for some years now with DGT experiments, but also a high resolution, which is a resolution that has not been used yet to see if we could obtain better quality images. And as a result, we can see the different distributions of some elements. Actually, we have analyzed a lot of elements and have a lot of different images. But these ones are some of the most interesting ones. For example, here in the acid mine drainage sample, we could see that some that manganese and lead, especially, they are more closely related to the chemistry of uranium in this sample than iron, for example, that we see a very different pattern. But when we analyze the high resolution images, we see that these remobilization patterns, they're actually linked to very specific hotspots, and they are common for all the elements that we studied. In this case, iron, manganese, and uranium, which means that the standard resolution image was not the best approach to obtain a clear picture of how these metals are remobilized and how what the chemistry of which element is related to other elements. We also analyzed samples that were not contaminated by acid mine drainage, like this one that we obtained outside the mine. And we see here a lot of features on the surface of the gel, which are indications of hotspots of contamination, and they are very they're considered with the image that we obtained for uranium, for example. However, in this case, this image was misleading because the hotspots that we could see in the pre-ablation sample were actually zones where no mobilization of uranium was seen, and actually they were zones of exclusive iron mobilization. So there are fundamentally different processes occurring in these two samples that I showed here, and this indicates that probably specialized iron-reducing organisms are controlling the speciation of iron in this area, for example. And we are still trying to understand how to explain these patterns that we obtained. But what we can say for sure is that using a high resolution image in this case allowed us to have a much better information on the processes that are occurring in the sediment water interface. And of course, this work can be used as a blueprint for new works in this sense. So as I mentioned before, the DGT imaging was a suitable tool to investigate these microprocesses as sediment water interface. We're seeing distinct mobilization patterns, and the sub 100 micrometers resolution was very effective. And we are trying to understand the relation between speciation of uranium and iron in these samples. So thank you very much, especially to FAPESP that has paid for all of this. Thank you very much.
Now? Jesus! Jesus guy. Você vai ter que abaixa tudo e deixa para baixo. Ou. Não. Ah, é que você não está duplicando, né? Você está.
Thank you.
Okay. Thank you, Professor Didier, for your invitation. Yes, for me it's important share my preliminary results for my research of doctorate in the Argentina. Yes. The title of the research is Impact of Two Planet Urbanization on Groundwater Quality in a Peri-urban area in Buenos Aires. I am Jesus. The project is advisor for the Asunción Romanelli and Mauricio Quiros is the principal advisor of the investigation. Okay. Before I start my presentation, for me it's very important contextualization my research. Yes. In this moment, it's very important talk about for the sustainable development goals. Yes. This aspect is the transversal for my investigation because it's the now 70 sustainable development goals explain different aspects for the different problems in this moment. My research tried the integration two goals, the goal 6 and 11. Is the more general is the aspect is the quality, quantity, and different aspect for the groundwater and water superficial. The other aspect is the sustainable cities and communities. This goal is specific in the urban grounds and the resilient cities. Okay. My investigation is the impact of groundwater quality and identify the source of contamination in the sewage urban sector of the city Mar del Plata. In this city, different activities confluence. Is the agriculture, disposition residual, and different activities change the characteristic of groundwater. Introduction. In this context, it's very important to talk about the groundwater pollution or overpumping is a preoccupation, it's a worry in this moment. It's a big problem. Yes, many studies in this moment, the pollution, specific, what is the source or what is the preoccupation for the different source, they change the characteristic groundwater. Pollen, nitrate, and bacteriologic microorganisms into of the groundwater and change the characteristic. When they change characteristic, is the limit they use for the different activities. It's important. Then say nitrate on pathologic microorganisms can cause different effects for the health of the people. One aspect important is when the planification of the cities make decision or they take decision don't have different aspects. For example, the people develop of cities seem we don't have the infrastructure. Yes, want to expand the different cities and the growth in the sanitary, the different conduction of the water not is possible. Okay, today technical convention is very common for the identification contamination of oil. Yes, but my work try to integrate other techniques. For example, isotopes, the nitrate and water for the explain different process in the change the characteristic water. Study area. Okay. My study area is the southeast of Buenos Aires. the name of the city is Mar del Plata. Mar del Plata is a second city, most important in Argentina. The reason is the city for tourists. Yes. In this zone, different activities conflude. The, the box, the yellow box, is the sanitary landfill. The blue box is the activities agriculture. The red box is the activities recreational, and my study is the green box. The particular result is that each house have a well domiciliary and POSI septic. Yes. Other characteristic in this zone is the aquifer pumping is only resource for the drinking water supply. Yes, it's necessary to protect for this area. The characteristic of aquifer is it's mostly unconfined and sediment is sealed and fine and layers the clay. In different areas, the aquifer is confined for the peak. Hydrological characteristic is the permeability is 10 and 20. Different styles, demonstration for this area is the low quantity water for the aquifer pumping. The principal point of recharge is the rainfall. In the percent of recharge is the 50.50% per year. Okay, the methodology. My group collect samples in different points. This presentation is a part of my investigation. I collect 11 points. The important aspect is that the point is distributed across the area. This aspect is very important for you to understand the quality local groundwater. One aspect important is the coastal line. The coastal line, I have 2 points blue. The point is the spring for the representation of the characteristic in this area. Okay, the monitoring variables is the major ions for the quantification in the hydrochemical characteristic and microbiologic analysis. And the other aspect is the nitrate and oxygen isotopes and stable water. The importance of the study is the integrate the nitrate and water isotopes for the identification of the source of contamination. The results. Okay. In both graph is the characteristic of groundwater in this zone. Is the characteristic principal is the calcium bicarbonate and sodium bicarbonate in this area. This aspect is very important for you to understand the different processes. Is the ionic chain and mineral dissolution or different aspects for possible integrate in the analysis isotopic. And the objective of my work is identify what is the source contamination or pollution in this area. The first approximation for the contamination is the relationship in this sodium nitrate versus chlorus versus chloride. It's important in different investigation talk about when the value is made of for the 0.1 the possible the origin or the source the nitrogen is the soil, yes, of the organic material. Other aspect is the important is the one the values is major. 10 in this graph, no show, but 10 is the agricultura is the input, the contamination. But other aspect important is the behavior of the point is the 4. In the straight line is the possible the contamination into is the constant is the same. For example, in this case, the preliminary result is the contribution is the from organic waste and wastewater. Okay, the microgeologic data show the 64 post well, sorry, well, don't possible when drinking because it's the pollution for the microorganisms. The aspect is very punctual. In the area, the people show the building of the well is very bad, and other aspect is the runoff into in the well, and they change the characteristic water. Okay, the topic is important. The isotope. And in the area, I quantification the isotopic stable water. Okay, the points red is the well, and other points is the spring, and star is the wastewater. What is the important? The preliminary conclusion is the red line is the local meteoric water developing from Mauricio Quiroz. The day is the near for the line. Is it possible the recharge of the groundwater is the rain? Yes, the collected sample is representation this situation. But the most important is the waste. Is the sample is enrichment, but it's possible. The preliminary conclusion is the wastewater in this zone is the mixture for the groundwater. It's possible, but I understand the isotopic different chains, the chain, the finger spring, for example, the evaporation, mixture, and fractionation change the finger spring. The final analysis is the isotopic nitrate. The isotopic nitrate is the more complex, but I need to understand what is the different transformation of nitrate in this area. The nitrate suffer different transformation for nitrification, denitrification, ammonification, volatilization, etc. And this process change the fingerprint of the nitrate. When they change the fingerprint, I don't know identification source pollution. Yes, but it's necessary other process for the integrate the water stable isotopic and nitrate isotopic for to understand this aspect. But in this area, the points, this graphic is the Kendall plot. Yes, so the Kendall plot is the has advantage and advantage. Uh, the principal advantage is the graphic is when the pollution is specific. In this area is represented for Mainuria and Switch. So this is wastewater and the agriculture, yes. But when in this aspect is very specific the contamination. But the disadvantage in this graphic is when the points is superposed. When the point is superposition in different box, I try why necessary to understand and integrate different isotopes. My problem in this area is the specific contamination, but I need other isotopic for the separate the pollution. For example, I need a quantification isotopic photo for the different in the human and animals contamination. Conclusion. The hydrogeochemical and microbiologic data afford information for the identification of contamination. The isotopic change the finger spring for different processes. Yes, I try to understand what is the principal process in this area. Finally, is the neutron isotopic is the specific contamination in this area.
I would like to invite all speakers to the table. We are a little bit in advance in our time, so I will allow one quick question for each.
The question is for Paula. And I understand that the group from USP, the Toro, and so on, they have shown that the contamination from chromium in urania is geogenic. At least this is what I understand from what they published. And in your presentation, I think you challenged this hypothesis, or why is the chromium contamination in São José do Rio Preto different from the chromium contamination in urania?
Well, at first, the contamination, they did look like, both did look like to be anthropogenic, but we did have the opportunity to look. And the thing is that in Urania, we do have just one formation there, and in São José do Rio Preto, we have 3 or 4. And these can change drastically what could be the source, since in Urania, the source of the contamination, it came from the deeper waters of the Adamantine. And also we had to check about the public water supply. They sort of reached us to see what we could do in order to manage these contaminations, so they could safely get water.
There are questions? So I have one. My point is about deep wells in Guarani outcrop areas. So my understand, or in my understand, probably we have a very huge water reservoir, and the biggest portion of this reservoir is filled by very old groundwater. It would be interesting to have